Now in this experiment, we will interface UART. Okay, we will interface UART. So first of all, in new project, you have to select the board. Our board is Nucleo 144, right? And part number is 767ZI. So click on new project. Again, initial all peripheral with their default mode. Click on yes. Now here you can see some of the pins are pre-configured, so you can clear all this. Now first of all, crystal frequency, crystal oscillator should be there, right? So in configuration part, first step is to connect this crystal with this RCC pin, right? Here you can see crystal oscillator in and out. And next is, since we want to implement or use UART from this board, okay, so what we are doing, uh, okay, in this microcontroller, we have UART 1, UART 2, 3, 6, 4, 5, 7, okay, many UARTs are there. So out of this, we will use UART 3, USART 3, right? So first of all, you have to set this into asynchronous mode, right? And here you can see we have two different pins enabled, okay? So you can check, this is actually UART TX pin number PB10, and this is UART RX pin number PB11. Okay, so we have configured this. Now in clock configuration, we will not do anything, we will not make any changes. In configuration part, you have to go in this UART, okay, and here you have to set some parameters. So let us change this baud rate to 9600, word length 8-bit, okay, and then we will save this setting, okay. And now you can check also in this, you can give your user label, you can give user label also along with this TX and RX pin, right? And now after this you can generate your source code, right? So again, for the same you have to click over here. Here you can give a name. So let us give name 3, UART 3, and in toolchain you have to select MDK ARM v5, okay, and then click on OK. So it will generate source code. Right, now you have to click on this open project, so it will open the project in ARM Keil Microvision 5, right? Now here you can see your user code, right? So again, in user code you can see based on our configuration some of the functions are there, okay. UART initialization is there, GPIO initialization is there, and user code you can write over here, right? And from this, yes, here also you can see, right, in this circuit we have connected this our board STM with Arduino, because what we will do, we will simply transfer message from this UART, okay. We will receive this message into Arduino and then we will check through terminal, right? So basically this Arduino is a receiver in this this term. Okay, and our board will transmit with baud rate of 9600, right? So now here you can see we have some of the drivers, right? So we have these few drivers are there, and here you can see we have this UART, right? So in this UART you can see multiple functions are there, right? And we will use one of the function called UART transmit, HAL UART transmit, right? So here you can see, you can search HAL, yes, HAL UART transmit, right? So we will use this function, okay, to transmit our data. And here you can see this definition of this function. So to call this function, we will simply copy, use this part, okay. And in main, since we want to transfer fixed message continuously, so we will put this function in infinite loop, okay. Now here we have to make some changes. So first of all, let us define message. Okay, so our message is unsigned character text. Okay, we are not giving any length, but our message is hello Shahrukh set, right? So this will be my message, okay, and I will transfer this message through UART. Now here you can see as an argument, here you have to give your UART handler, right? With UART, on which UART you want to transfer your message. Here you have to pass your data. Here you have to give the size of the data and timeout. Okay, so after this much tick, you can see instant, this function will time out, right? And here again you can see based on our configuration in UART, baud rate is there, right? Stop bit, parity bit. So this is based on our configuration, right? So this is UART 3, okay. So what we will do now next, we will change this argument. Okay, so first of all, since we are working with UART 3, so here you have to type UART 3, right? And here you have to send the data. Okay, so our data is stored in character array, so we will write text, okay. Then here you have to give size, so you can use this function size of text, right? And here timeout, in timeout, basically you have to give any number, but your number should be greater than this length, right? So let us give any number, okay, maximum 100 number we are giving. So this will continuously send this message on UART 3 with baud rate of 9600. Now let us add some delay. So this is what the code. So we are now will simply build the project. Okay, so it will build the project and it will generate binary files. Okay, and here you can see in the circuit also, since we are using this 2 pin, right, PB10 and PB11. So from this manual you have to check. Okay, here you can see for our part number, which is Nucleo F767ZI. This is the pin configuration, right? And here you can see this is CN8, this is CN9. Here in this image you can see CN8, CN9, CN7 and CN10, right? And here in CN10 you can see our PB10E and PB11. These two pins are there, okay, where these wires are connected here in this uh, interface you can see. So basically PB10 is transmitter, right? So PB10 is transmitter and PB11 is a receiver. So here you can see transmitter is connected with the receiver of this UART of this Arduino, right? And receiver is connected with the transmitter. So this is what the connection. Two wires are used, one for transmitter, one for receiver, okay, based on this. And now code is compiled. Now we will simply load this code on our board, right? So you can see, okay, so now code is there on this board. Now to check what we will do, we will use simple this real term, right? So here you can capture the from the terminal. So you can select port, you can capture the string from this serial interface. So now my Arduino is connected with port 6, right? And because Arduino will receive the data, so here we will simply check the data from this Arduino board, okay? Connections are there. So when I will press reset, this STM board will send data on this wire. Arduino will receive the data, and we are using this Arduino as a receiver, right? So on this custom what we can say receiver, Arduino will receive the data, and then on internal transmitter pin it will send the data. So from this USB cable we can receive the data, right? So now let us open this port, okay, and now we will simply press reset button over here, right? And now you can see STM is sending this data, hello Charuset, and this Arduino is receiving the data, right? And then you can observe this data. Baud rate is 9600, right? And this is how you can transfer your message. You can transfer your data from the UART of this STM microcontroller.